Today we're looking at Lesson 11. This is the beginning of the polynomials section of Unit 1. In order to get started with adding and subtracting polynomials, we're going to go through some vocabulary. Now, polynomial itself is an expression that has algebraic terms in it. An expression with algebraic terms. So how many algebraic terms? Well, the poly part of that word, poly just means many. So it's a generic term meaning multiple terms in the expression. There are some more specific ways we can identify those expressions. So a monomial has one algebraic term. Okay, so for example, 2x. That's a monomial. It only has one term. Mono means one. Bi tells us how many terms go in the next one. Bi, like die, can mean two. So this has two terms. So for example, 3x squared plus 2x. That's a binomial because there's two terms. So it's not too hard to figure out what a trinomial is going to look like. So a trinomial has three terms. For example, 3x squared plus 2x minus 5. So there's three separate terms there. So how are we going to add and subtract polynomials? Well, we're going to start at the basics by adding and subtracting monomials, or one term from each other. But there's something really important that we have to understand about adding and subtracting these types of terms. It's a little bit like adding and subtracting fractions. Only certain kinds can be added together or subtracted from each other. And what we have is this phrase, like terms. Now we say we can only add and subtract like terms. And like terms must have the same variables and, very important, the same exponents on those variables. Okay, the same variables and the same exponents. So let's take a look at these terms. And let's try and identify the like terms. Remember, the same variable, the same exponents. So let's look at 3x. I'm going to put a circle around 3x. Now, 3x has a like term in here, and it's minus 7x. So you see the variable is x, and the exponent is 1. Let's do 45y cubed. I'm going to put a rectangle around 45y cubed. Now I want you to take a look through there and see if you can identify the other like term to 45y cubed. And you're right, it's minus 4y cubed. So what about this one? 5fg to the exponent 4. So we need to find something that has an f to the exponent 1 and a g to the exponent 4. And that's down in this corner here. Okay. And let's look at this negative 14 n m to the power of 5 p to the power of 4. Down here has the same exponents and same variables. Is there anything that negative 9 x, y, z squared could add or subtract to in this section? No, because it has no like terms. So let's see how we apply this in practice. So let's take a look. Now, we're going to simplify, and simplify means we take it to its simplest form, as opposed to evaluate, which means we have to have a numerical answer. So be careful when you're answering questions, look for what the instruction tells you. So in this case, we're simplifying. And let's look at 5x plus 7x. 5x plus 7x, are they like terms? Yes, they are like terms. That's great. That means that we are able to add and subtract them together. So let's think about this. 5x is the same as x plus x plus x plus x plus x, right? Remembering that multiplication is repeated addition. Like exponents are repeated multiplication, we can use this identity to help us create new rules. So if 5x is that, and we're going to add 7x, which is 1, 2, 3, 4, 5, 6, 7. If we add those together, we're just adding a whole bunch of x's to a whole bunch of x's. And what we're going to actually get is, what's 5 plus 7? 5 plus 7 is 12. 12 what? 12x. That's why we have to have like terms. We can't add x squareds to these x's. They're not the same thing. If I gave you 3 apples and said, add these apples together, how many apples would you have? You'd say 3 apples. If I then gave you 2 more apples, said, how many apples do you have now? You'd say 5 apples. But if I gave you 2 oranges, you'd have to say 3 apples, 2 oranges. You couldn't add them together. And that's exactly what these like terms are. If the variables and exponents are not exactly the same, they're like the oranges that are being added to your equation. You have to just leave them as oranges. You can't make them into apples. Okay, so you have to be very careful. Again, it's a lot like adding and subtracting fractions. These specific rules have to be followed. Let's look at the next one. Y plus negative 5y. So now you might say there's no number here, but secretly that's 1y. Just like we don't put the 1 in on exponents, we don't often write the 1 in front of a variable because it's implied that if it's just y, there is only one of them. So we're going to treat this again much like the variables aren't there because we know they're like terms. So we're going to say, what's 1 minus 5? And that's going to give us minus 4. Minus 4 what? Minus 4y. And that's the same as saying I have 1y. I'm going to plus negative 5y. So that's the same as saying minus 5y. So we're going to take away y, take away y, take away y, take away another y, and another y. So positive y minus y is 0. And then there's minus 4y. So it all works out. Let's take a look down here. Number 3, 2x cubed yz minus, okay, plus the negative 3x cubed yz. Are they like terms? Yes. So I can do that. 2 minus 3 is negative. Do I have to write the 1? I don't actually have to write the 1. X cubed yz. Note the variables never ever change when you're doing this. Unlike when you're doing the power rules, the exponent rules, then the variables do change because everything's working with multiplication. Because we're adding and subtracting the variables, the exponents on them will never change. What about this one? What happens to that one? It's like that orange that we can't put into the apples equation. So we're just going to leave it on the end, like that. And that's the correct answer. So, we're going to get more complex for a second. And this is the level that you're going to be practicing in class. Binomials and trinomials and even polynomials with more terms than 3. So let's take a look. I need to get rid of the brackets. The brackets are not helping in this case. So I need to get rid of the brackets. And how do I get rid of the brackets? I do that by expanding them, something we're going to look at in further detail. And there's nothing in front of this bracket here that's going to change what's inside that bracket. So my first step is just going to be to remove those brackets. I don't need them. But this right here, okay, this minus sign is a problem. That minus sign says that you're going to subtract all of 3x plus 8. So what you're actually doing, we have to apply that minus sign by multiplying it to everything. You're going to say minus 3x minus 8. That's really important. That's a step a lot of students forget to take. So you must expand that bracket. How does that work? Remember, if I said we have 2 times, let's say, 4, what do I need to do? 2 minus 4 plus 8. The rules of Bedmans tell us to do the brackets first. So then we go 2 minus 4 plus 8 is 12. 2 minus 12 is negative 10. Right? If you just took those brackets away and did 2 minus 4 plus 8, you would do minus 2 plus 8. You would get 6. You can't do that. It's incorrect. But that's why we go 2 minus 4 plus 8 becomes 2 minus 4 minus 8 because I expand the bracket by multiplying the negative through. And that is going to give us minus 10. Okay, so that's why that works. So you can take it on faith that that's what's happening. So let's continue. We're going to collect our like terms. We're going to go 5x minus 3x. Plus 2 minus 8. I'm just moving these around to make my life easier. 5x minus 3x is 2x. 2 minus 8 is minus 6. Okay, we're going to quick do one more. All right, so again, I have this persnickety problem of this negative. Okay, I'm subtracting everything inside the bracket. So we know that that's going to apply to all 3 terms. I'm going to get 3x squared plus 2x minus 6. Here we go, minus 2x squared minus 8x, and then a minus times a minus is positive 16. So it basically just changes the sign of everything that's in there. Okay. So now we're going to figure out the rearrangement. So I'm going to take all my x squareds together, 3x squared minus 2x squared. I'm going to put all my x's together, plus 2x minus 8x. And I have minus 6 and plus 16 left over. This stage is called collecting like terms. It's very important. I will be looking for it on your assessments. 3x squared minus 2x squared is 1x squared, which I just write as x squared. 2 minus 8 is minus 6x, and negative 6 plus 16 is positive 10. And that's your final answer.